And welcome to the Sociology 3 Module 12 video lecture on deductive and inductive reasoning. This week we're going to take a bit of a break from the Brown and Keeley text and focus on a topic that's actually required of all Area A3 courses, which is to talk about differences between deductive and inductive types of reasoning. This is a topic that you might have come across if you've taken perhaps a philosophy course or a logic course, but for many of you, I know this is going to be the first time that you've had any exposure to these different types of reasonings. And the reading that I assigned for this week, let's just say I recognize that it's a little bit complicated, so I wanted to use our time during the video lecture this week to guide you through some simple but very illustrative examples of the differences between these two very important forms of reasoning. So first, isn't that cute? The picture of the kitty. I want you to consider the following argument. Premise 1, all pictures of kittens are cute. Premise 2, this is a picture of a kitten. Conclusion, therefore this picture is cute. The critical question here is, how do we know that this conclusion, the picture is cute, is valid based on this reasoning structure? Well, think about it. If premise 1 is true, all pictures of kittens are cute, and premise 2 is true, this is indeed a picture of a kitten, based on the premises, the conclusion necessarily has to be true. And I don't know about you, but that is one pretty cute kitten in my opinion. So what we have here is something called a deductive argument. This is also called deductive reasoning or sometimes deduction. It's a basic and primary form of valid reasoning because it's an effective way to organize or structure an argument. And if you think about it, the scientific method actually uses deduction to test hypotheses and theories. So it's a very important type of reasoning structure, which is why it's required that we learn about it as part of our critical thinking course. So what exactly is deduction or deductive reasoning? Well, you can think of it as a type of reasoning or logic that starts with a general statement, or if we're thinking about it in terms of the scientific method, a hypothesis, and examines the possibilities to reach a very specific logical conclusion. So the way I learn to differentiate between deductive logic and inductive logic, it's really hard for me to keep these two things straight often, is to think about it as an upside-down triangle. So we can think of deductive logic as really a top-down approach. So the observer or the critical thinker starts with very broad premises, such as all pictures of kittens are cute, and then works their way down to very specific conclusions. This is a picture of a kitten, therefore this particular picture is cute. And the one thing that the main thing you want to remember about deductive arguments is, if the premises are true, the conclusion must be true as well. The reading emphasizes this, and everything that you're ever going to read about deductive logic will emphasize this core truth. If the premises are true, the conclusion must be true as well. So there are several different major kinds of deductive arguments that you'll often come across, and I know the reading this week on deductive versus inductive reasoning goes over a lot of different types, but I want to draw your attention in the lecture to some of the more common ones. So the first one I want to talk about is called modus ponens. This is a Latin for the mode of putting. It's really the simplest form of a valid deductive argument that basically goes like this. First premise, if A, then B. Second premise, A is true. Then conclusion, therefore B is true. So our picture of the kitten example would be a type of a modus ponens argument. Let me give you another example here, okay? So if drivers on cell phones have more accidents, A, then drivers should be prohibited from using them, B. Okay, first premise. Drivers on cell phones do have more accidents, A, therefore drivers should be prohibited from using cell phones, B. So for modus ponens to work and be a valid deductive argument, you really have to be able to defend both premises. Both A and B, therefore, have to be true. Now consider the following. Premise 1, all bald men are grandfathers. Premise 2, Benjamin is bald. Conclusion, therefore, Benjamin is a grandfather. So the critical thinking question here is, what's wrong with this argument? Are any of those statements and especially looking at premises 1 and premise 2, are they perhaps not correct? Well, if your critical thinking eyes went up and said, wait a second, not all bald men are grandfathers. There are a lot of bald men who aren't grandfathers. You are indeed correct. So this is an example of how you can have a logical argument structure, but again, with deductive arguments, you want to remember, as long as the premises are both true, or if there are more than two premises, as long as all of the premises are true, you can assume the conclusion is true. But the problem comes in when one of your premises is not necessarily true, as in this case that all bald men are grandfathers. So what we want to remember, premises must be valid. The premises must be true in a deductive argument. So it's possible to come to a logical conclusion to follow that logical structure even if the premise is not true. If the premise is wrong, the conclusion may be logical, but it may also be untrue. So what I mean by logical here, I know sometimes we use the word logical to mean correct. That logically sounds right, we might say, but logic doesn't mean that in this context. It means it follows a proper reasoning structure. But again, I know I'm sounding like a broken record here, but it's so important. This is the main takeaway with deductive arguments. If your premises are true, your conclusion is true. However, if your premises are not true, then you can oftentimes have an untrue conclusion. A second major type of deductive argument is called modus tollens, or the mode of taking. This is another very simple and common valid argument form. If A, then B. A is not true, therefore B is not true. Let's look at an example here. Another cute animal picture. I'm a big animal fan. Premise 1, if the visitor were a stranger, then the dog would have barked. Premise 2, the dog did not bark. Conclusion, therefore the visitor was not a stranger. So very similar to modus ponens, but one of the premises is basically in the negative form. Another very common one is called a syllogism, another valid form of deductive reasoning. So you have two statements, a major premise and a minor premise, and you use those to reach a logical conclusion. So if A, then B, if B, then C, therefore if A, then C. Okay, I'm using these kind of simple A, B, C statements to just map out the structure of the argument, but if you're anything like me, examples are so much easier to follow. So that's why I provide you all a lot of examples. So here's our major premise. If you come to class, you will know what will be on the exam. Minor premise. If you know what will be on the exam, you will make a better grade. Conclusion. Therefore, if you come to class, you will make a better grade. So this is a very clear example of a syllogism, which is a kind of deductive argument. So what about inductive reasoning, right? Because we're talking this week about differences between deductive and inductive approaches. So inductive reasoning really works in the opposite way. So it's kind of we can think of it as the opposite of deductive reasoning. So instead of a top-down approach, that inverted triangle with the broader base at the top, we can think of inductive reasoning as a bottom-up approach. Because what happens is an observer, or critical thinker, really moves from specific observations to broader generalizations and theories. So we can think of that as a right side up triangle. Now here's the problem with inductive arguments, as the reading clearly states. Inductive arguments are not always considered logically valid because you can't assume that a general principle is correct based on only one or a few observations or cases. And if you recall, we've actually talked about the same type of theme many times throughout the semester. Recall our previous class discussions about stereotyping. Sometimes we will stereotype an individual based on their membership in a particular group about which we hold stereotypical views. And this is also one of the problems with using personal observations as evidence, because we can't just focus on one specific case or one person's experience to make broader generalizable conclusions. That's usually very problematic. And that's also what tends to be problematic about a lot of cases of inductive reasoning. So again, here's an example. I learn better through examples, and I'm sure many of you out there are like me. So I want you to think about this example here about driving to work, and I want you, as I go through these two cases, to ask yourself which one is using deductive logic and which one is using inductive logic. So, case 1. Today I left for work at 7:45 and I arrived on time. Therefore, every day that I leave the house at 7:45, I will arrive to work on time. Now, is that deductive logic or is that an example of inductive logic? If you guessed inductive logic, you're absolutely correct. Remember, inductive logic relies on one or a few specific observations. So in this case, I left for work today at 7:45 and I arrived on time this one time, right? And that person's making the assumption that just because it happened once, there was one case, one day of driving to work, that every day if they leave the house at 7:45, they'll arrive to work on time. Well, the problem with this reasoning structure, you can think about it in terms of this example, is that there might be many reasons that you could leave for work at 7:45, and because maybe conditions, traffic conditions, or weather conditions are different on a different day, you might not always get to work on time. So let's consider case 2. Every morning, I leave for work in my car at 7:45 a.m. Every day, the drive to work takes 15 minutes, and I arrive on time. Therefore, if I leave for work at 7:45 today, I will be on time. Is that inductive or deductive? Well, if you guessed that that was deductive, you were absolutely correct. Notice this person is relying on a reasoning structure where there's a general pattern of experiences. Every day you leave for work at 7:45, and despite those differing conditions, every day you arrive to work on time, so you can assume that the very next morning, if you leave for work at 7:45, you're going to arrive on time. So you've actually probably used deductive and inductive logic at different points in your life. And you're probably, right, you're catching on to what the reading was saying, which is that deductive logic is just a better type of reasoning structure because it's a more valid type of reasoning. It allows us to reach more correct conclusions. So finally, I want to end on this point that even though deductive logic tends to be a more valid type of reasoning, we actually need both deductive and inductive processes. Because inductive reasoning is often good for the initial stages of information gathering, because we often don't have enough information about a particular topic to form a broad generalization. Go back to the previous example, right? Say you live where you live now and it takes you so long to get to work, and you have a pretty good sense that if you leave by a certain time every day, you're going to get to work every day on time. But the first time that you were driving that route, you didn't really know, right? So you had to start off with day 1 and then day 2, and you had to go through and experience a pattern of driving to actually be able to make a more generalizable statement that if I leave at 7:45, I'll get to work on time every day. So really, until we have a broad base of information, inductive reasoning allows us to develop specific hypotheses that we ultimately test through deductive logic. And so I really like this image that I included on the slide here. Notice that deductive reasoning and inductive reasoning can really be thought of as this really nice feedback loop. So you can use a specific observation or case, and we can use inductive reasoning to start to form general principles, but then we test those general principles through deductive reasoning. And that's actually how we as researchers, social scientific researchers, use both deductive and inductive logic in our research. So I hope that this video lecture was helpful. I know that this week's reading was, I tend to find it to be one of the more complicated readings in the course. So I hope that this lecture was helpful for clarifying many of the major points in that reading. Have a wonderful week and go out there and use your deductive and inductive reasoning. See you soon.